Hello, this is a short follow-up video to one of the skills that we practiced in the last lesson, and that's using completing the square to rewrite when you have definition form to change it into vertex form. The most common comment on the Edpuzzle from the other day was not really liking completing the square and a couple of requests for a little more instruction on that. So if you want to try these three problems and just check your own answers because you feel fairly confident, I'm going to show those answers right now. If you want to go through the video with me instead, then just avert your eyes for a moment because here come the answers. All right, so those are the answers. You can try them out on your own. And the video is not an Edpuzzle, so you can just skip around and see whatever parts you want. All right, let's go ahead and get started. So the first one is kind of a more basic example because the coefficient of x squared is 1. Those are always a little easier when it comes to completing the square. So here's the process we're going to go through. The first job is to move c by itself. So what I'm talking about here is I have ax squared plus bx plus c. So what I'm going to do is group the ax squared and the bx, and I'm going to move c outside of the parentheses all by himself. Then my next job is to get a equal to 1 unless it already is. So here, see how my a value is already 1 because the coefficient of x squared is 1. So that's what makes this one a little easier is I don't have to take that step. Next, we're going to find b over 2. That's the magic number. You kind of have to memorize that as a formula. And once you find b over 2, you're going to add that number inside the parentheses. So b over 2 squared is going to be 6 over 2 squared. And 3 squared is 9. So that's the magic number. And what we're going to do is we're going to add that number inside the parentheses because now we can factor that trinomial. But I have to make sure that I've added 0 total. So I like to call this balancing. So what happened was these two sides were equal. So this was equal to this. And what we just did is we added 9. So now this side is 9 more than it used to be. So what I have to do is out here, I have to subtract 9. Because what I've done altogether is the change that I've made from this expression is I've added 9 and subtracted 9. That total is 0. So if we think of like a balance, so we think of a balance and they used to be balanced, those two sides. And when I added the 9, I threw it off. So I had to subtract 9 to make sure it was 0 altogether. Our final step here is to factor and combine our constants. When we factor this, we should get a repeat of a binomial. I'm going to combine those constants. And to write this in vertex form, instead of x plus 3 times x plus 3, I rewrite that as that quantity squared and then a plus 1. Now, let's go ahead to number 2, which is going to be a little more complicated. So for number 2, we're going to take pretty much the same steps, but because of the 3 in front of the x squared, it's going to be a little more complicated. So here we go. So our first job is to move c by itself. So I'm going to group ax squared and bx and move c outside the parentheses all by itself. Now my next step is to get a equal to 1 if it's not already. Here my a is 3. So what I want to do is I want to factor out a 3 from these two terms. So I'm going to factor this 3 out to the front. I'm going to factor a 3 out of the minus 12x. But I'm going to leave 17 as is because he's not inside those parentheses. He's been isolated over there all by himself outside the parentheses. Our next job is to find b over 2 squared and add that value here. When we find b over 2 squared, we need to use this b right here, whatever's in after we factor out the a. So we don't want to use negative 12 here. We want to use negative 4. I call it the new b. So we use the new b. You're going to divide it by 2 and then square. So that value is 4. So what we want to do is right here, we're going to put a plus 4. So again, this side and this side used to be equal to each other. They're balanced. By putting a plus 4 here, I've thrown off the balance. So what I need to do is I need to find out what number to put out here so that I've added 0 altogether. So here I wrote 4, but that's not really what I added. Because this 3 would have to get distributed in, I've really added 12. So by writing a plus 4 here, I've really added 12. So to balance that, I have to subtract 12. And now I can factor and combine the constants. And I should always get a repeated factor when I do this process. And that should be my final answer in vertex form. And the third one is going to be the trickiest one here, because I've not only put a number in front of the x squared, but I've also made it a negative. So it's going to be a little extra tricky. So first step, make C lonely. So we're going to move C, the -8. We're going to move that out to the side all by itself. Now we need A to be equal to 1. Since this is ax squared plus bx plus c, we need to factor out that -2. And be careful when you do that, because when you factor out a -2 here, this term is going to become a plus 2x. So when you factor out the -2, it's like you're dividing this by -2, so I get x squared. You're dividing this by -2, so I get 2x. If you were to distribute the -2 back in, you'd end up right back here. And again, as I mentioned in the lesson the other day, it is possible to do this step and then this step, but I've very rarely seen someone get it correct. So make sure you're doing this first. Make sure you move C by itself and then get A equal to 1. Now we need to find B over 2 and square it. I don't want to use the -4. I want to use what I call the new B. Use the B that you have after you factor out the A. So I'm going to do 2 over 2 squared. 1 squared is 1. So the number that I'm going to add inside is 1, because now this trinomial factors. Now by putting a 1 here, I need to balance, because this side and this side were equal. See, this side and this side are equal. So right now these are equal. Right now these are equal. When I put a plus 1 here, I'm throwing off that balance. So I have to find the correct number to put on the outside so that I've added 0 altogether. So to find that number, we need to think about what we really added. I wrote plus 1, but because this -2 is out front, I really added -2. So if I have taken this side and I've subtracted 2 to balance it out, I have to add 2 back, because then I've added 0 altogether. So if we factor and combine the constants, we should have a perfect square of a binomial. We should have a repeated factor. And this should be our final answer in vertex form. And one last thing to mention is, as you practice this and get more efficient at it, you might show way fewer steps than I'm showing here. I'm showing every possible step because it helps when you're trying to see the process. But if I were doing this on my own with this problem, I know that I'm going to factor out an A. And I know that the C is going to be out here by itself. So I kind of do those 2 steps at once. And then when I find the B over 2 squared, I put a plus 1 here. And I know that what I really added was -2. So if I have -2, I have to plus 2 to balance it. See, so all of these steps I actually usually do in one step. And then I know that this is going to be x plus 1 times x plus 1. So I usually jump right down to writing the quantity squared. So if I were doing this for myself, I would have 1 step of work and then my answer. Feel free to show all the steps, but just in case as you're doing your own work, you realize that you're doing it in way fewer steps. That's why I've expanded it here to show every possible step of that process. Hope that helps.